When we last left off, we had integrated this one. Since then, a little bit of time has passed in between videos, and the sun is now setting, as you can see. So it's coming through the window with the blinds closed. So I'm going to erase this problem so we can do the next problem, but there's something I'm going to keep on the board, and you're going to see why in a minute. Let's erase, oh, not that. That's what I'm keeping on the board. So let's go here and write the next problem, which is going to be a little bit ridiculous, and this is going to be a problem where we have to complete the square in order to actually integrate this. So here we go. This problem is 5 over x squared plus 6x plus 25, and then dx. Okay, let's talk about what not to do, just ignoring the fact that I'm telling you where this is going. Let's talk about what not to do. Do not, because it won't get you anywhere, treat the denominator as if it was u, because if we treated the denominator as u, then u prime would be 2x plus 6, and there's no way you're going to get that anywhere else in this problem. So that's not going to work. We also might be tempted to factor that denominator. It doesn't factor. I'm sorry, but it just doesn't. So what I am going to do is turn it into this format, and it's very doable. So here's what I'm looking at. I'm looking at the structure of this problem right here and saying, you know what, this may not look like this, but if I squint hard enough, and I'm not wearing my glasses so it might work, if I squint hard enough, it will look like this. And we'll stand in the way so the sun doesn't shine and hit this one. Well, it's hitting me instead. So we have u squared, which involves a variable, so x squared, and then we have another perfect square, which is 25. And again, that perfect square doesn't have to be a perfect square. In a previous problem, that perfect square was 5, which means we really had the square root of 5 times the square root of 5, right? So you can kind of force it to be the square that you want it to be by taking the square root of something and it being irrational. It works. So I want this to be the basis of what I do here, which means I'm going to, just for the sake of making it truly look like this, I'm going to rearrange a few things. So let's go here and let's do this. We're going to say this is, let's call it 5. And we'll say 1 over, let's see, 25 plus x squared plus 6x. Okay. And then we're going to do this thing that used to be taught in Algebra 2, when we taught it as Algebra 2. It's called completing the square. So let's pause this lesson and do a different lesson inside a lesson. And I'm going to write a series of perfect square trinomials. Those perfect square trinomials are going to be, well, trinomials that factor into a binomial squared. So for example, not related to this problem, if I wrote x squared plus 10x plus 25, again, not related to this problem, I know that one has a 25. I could say, oh, this is really x plus 5 times x plus 5, so it's x plus 5 squared. Could totally do that. Totally do that. So if I had x squared minus 12x plus something, okay, I want to figure out what that something is to where this would factor into a binomial squared. And in this case, we can go ahead and figure out what that binomial squared is. Notice the previous problem. That 10 helped us get the 25, even if you didn't know it. I kind of made it up with this in my head. So 5 is half of 10, so there it is. Also, the square root of 25 is 5. So half of 12 is 6, negative 12 actually. And if I squared that 6, I'd get 36, okay? So knowing that this is our basic format for this, let's take this idea, and we're going to put some parentheses in strategic places here. Let's take this idea and we'll do this right there. And we're going to fill in a blank right here. And when we fill in that blank, we're going to have to be able that we balance things out appropriately. And you'll see where this is going in a second. You can hear the, what's it called? The guide, the Zamboni for the floor. All right. I want to fill in a blank here. Let's come back to this idea. I want to fill in a blank here with a number that would create a perfect square trinomial. And I am going to, well, decide what goes here. Let's do that first. That would be half of 6, positive 6, so it's positive 3. And then if I squared that 3, I'd get 9. So here's what's going on. I could put a 9 right there. Okay, well, that's fantastic. I have just done something very wrong. I mean, keep it, but we have to fix it. Because if I'm just going to add 9 in a denominator, then I can't just add 9 without also subtracting 9. So what I've really done is balance this out. I've added 9 and subtracted 9. So I haven't truly changed it. I've changed its appearance, but not its value. So let us proceed a little bit further. And what I really have is the sun shining on the board. I have the integral 1 over, and then 25 minus 9, which is 16, plus, and we'll go ahead and factor this, x plus 3, and it is squared, and then we have dx right there. All right, keeping that in mind, we now know all the little components that we need to know to make this look like this, right? Okay, you with me? I have no way of knowing because this is a video. So let's just identify a few things. You don't have to write all the stuff down that I'm going to write. I'm going to put it over here on the side. So if a squared was 16, then a would be 4. I know that. You know that. Easy to identify. X plus 3 squared is, this is way too much information here. X plus 3 squared is u squared. So u is x plus 3. And then you can get all crazy and be like, well, I'll take the derivative of that, and du equals 1 dx. And you've got what you need. I factored the 5 out from the beginning. It was just going to complicate my life. So let's just go ahead and finish the problem, knowing that what we have is 5, and then all the rest of this over here. So 1 over a. 5 times 1 over a. Well, let's just call it 5 times 1/4, so 5/4. And then arctan of u over a, so x plus 3 over 4, and then plus c. And it totally works. If you took the derivative of this, you go right back here. It'd take a little bit of work, but you could do it. You stand there, there, there. I'm going to try to stand just in the right place where it blocks the sun on that one. There we go. All right, there's your final answer. And that final answer, if you took the derivative of it, would take you back to the original problem. Now, the question is, how do you identify that that's what you do, which I mentioned briefly at the beginning, and it's this. I see a structure that isn't very doable. Again, can't factor the denominator, and if I dealt strategically with this, I could force it to look like that, and that has a very regimented format for integrating. So we're going to do the next problem, and the next problem is going to be very similar, but it's going to have just a few differences as well. So let's erase this little lesson within a lesson. Let's keep that integral symbol because it's so nice and pretty, and I'm going to need it. And the next problem says, oh, this is a fun one. I want to make sure I copy it correctly because my copy and your copy are a little bit different. So I'm going to use what is the equivalent of your copy. 7 over the square root of negative 16 minus 10x minus x squared, and then dx. Okay, we're about to pull out an old formula. The derivative of arcsine involves all kinds of crazy stuff, but it is, the derivative of arcsine is 1 over square root of 1 minus x squared. To make this a little more chain rulable and undoable, the actual format for this, and this goes back to a formula sheet that you have, is the integral of du over the square root of a squared minus u squared equals arcsine of u over a, and then of course plus c. All right, so there's our formula. Let me glance at it for a second and make sure I'm not accidentally lying to you. I am not. We're good. And I want this to look like this. Well, how do I know? Well, because that's what we're doing in this lesson. But how else do I really know if that wasn't the context of what we're doing? Let me tell you. Again, looking at the denominator, maybe the stuff inside the square root is u. Write that down. U equals all this stuff. Take the derivative. It'll never show up anywhere else. You're going to have a problem trying to figure that out. So at this point, I'm looking at it, I see a perfect square down there in the denominator under that square root. I think it's going to look like that. I hear the Zamboni going by. Not sure if the microphone's picking it up or not. I'm recording this one differently than I have the other one, so you might hear it. We'll see. All right, I'm going to beat this into submission to make it look like that. So let's do it. We're going to have, we'll bring it over here. First of all, that 7 is just not something I want to deal with. Just put it in the front. So 7 times the integral of all this fantasticness that's about to take place, and it's going to look like that. So dx can come up on the top. I'm going to leave it as a 1. We'll put our dx over on the side. It really doesn't matter. But it is under this square root, this radical, where all the action is going to take place. And all that action is really going to be negative 16 minus, okay, now that negative 16 minus, I'm going to leave a little space there because I'm going to need to put a blank. Now if you're looking at this saying, okay, a squared is negative 16, now we're playing with imaginary numbers, hold that thought, okay. In a minute, I'm going to have to put a blank here and clean something up, all right? It's going to have to happen. In the meantime, actually, let's extend this a little bit further. In the meantime, I will subtract some stuff. What stuff am I subtracting? Well, first of all, let's rearrange this. I'm going to take this and just kind of make it negative x squared minus 10x. That's those just rearranged. I like to have the x first. Now, I like to have the x first, and I know I have the negative 16 first. That sort of follows this format here. But we're going to rearrange that, and I could factor out the negative and make it x squared plus 10x. Could totally do that. Totally. And that's actually what I'm about to do. I feel like there's a timer on it. Like, by the time this reaches the top of the board, the video has to be over. So like the sun comes in and you got to like beat the sun. Anyway, so x squared plus 10x. X squared plus 10x plus something. And this is that perfect square trinomial thing. This was actually the first example we did. And that thing is 25. I would take half of 10, 5, and then square it. And it works. And you could factor it that way. So 25. So I have just, I would say I added 25. I would say I added 25. I would say I added 25, and it looks like I did, but let's be real honest. I technically subtracted 25, right? I did. Subtracted 25. So if I'm going to subtract 25, I truly do need to add 25. So what I've truly done, like if I just dropped all my parentheses after distributing, I could simplify this thing right back to here. I could. Don't want to. I do working backwards. So 25 minus 25, they'd cancel out. So we are in a position now to where we could, well, do this correctly and write the dx, because I erased it so I can extend the fraction bar. There we go. That's better. And we will proceed with this process. We'll bring it down here. 7 hangs around. By the way, final answer is going to have a 7 in the front. It just will. If I put a 7 here, I'd put a 7 here. It's going to happen. So 7 times the integral of 1 over, all right, negative 16 plus 25, that's 9. And that's convenient. That's a perfect square. It doesn't have to be a perfect square. You could just take the square root of an irrational. You could take the square root of a number and make it irrational. That's fine. But this one's going to work out nicely. Minus, and we'll make that one squared. So that's x plus 5. And we have dx. At this point, we have so much of the correct format staring us in the face that we can grab the green marker and identify things. I'm going to write way too much here. Don't write all this. But 9 is a squared, so a is 3. And that at least goes through your head, whether you write it all on paper or not. X plus 5 squared is u squared, so u is x plus 5, which means du, let's get that font a little better, is dx, 1 dx. I know it was a 7, we factored the 7 out. So we are ready to just put this in final answer format, put a 7 in the front, ready to go. Here it is. 7. And then arcsine of u over a, so x plus 5 over 3, and then plus c, and we're finished. That's it. If you took the derivative of that, you'd end up back where you started. It'd be sloppy, but you'd get there.